Hello, everybody. Just to let you know that I do a lot of work here at Haverford College and using product placement to say thank you to the people who help me. I do a lot by our Koshland Integrated Natural Science Center and such, so Walter can surmise that. So let me see if I can get the guitar first. Hopefully that won't crash. I'm a little more worried about that than the computer. So I want to share screen, if I remember doing this last time. And oh, that's the one I want, right? So I want this over here. And I want desktop 1. Did it go? Oh, I have to share computer sound and share that desktop. There we go. Is that okay? Is anybody? Wow, I don't see anything. Hello?
Looks fine to me, JB.
I wanted to go there. There we go. All right. So, hello everybody, good afternoon. I'm going to be talking about something which we use here to get people interested in concepts in computer science, and that's computational composing, getting people to write music. So here's the plan. I want to first of all convince you that this really is a thing. If you looked at the presentations yesterday, you would already know it's really a thing. In fact, it's a pretty big thing. So I'm also going to talk about what it's not, why we do this, and I'm going to talk about how I compose things using the term algorithm, but it's not really an algorithm. And then I have 1 or 2 examples if time permits. And then some stuff I'm doing to assess how well it works and then what I'm going to do in the future. So here's a couple people that I know who do this stuff. I call them the people who are not in computer science. You might know Tom Lehrer and Al Yankovic, Weird Al. And then down the hall from me is Walter Smith, who's on this conversation right now, doing physics songs, who made it permissible for me to do this at Haverford College and not lose my job. But it is also found out it's been done a lot in computing. So all the people that are listed there on the right, Don Knuth is a very big name. If you use tech or LaTeX, he's the one who invented that. David Pogue used to work for the New York Times. Michael Littman, I've seen on TV as one of those commercials. I forget where it was, but he's now at Brown and has some great videos that talk about how to do sorting. Look for the sorter on YouTube. And Steve Wolfman's at University of British Columbia. And I have all links to some of their pages on the slides, which I hope will be available after the talk, and you can get to those links themselves. So this is what it's not, and I want to make sure that's clear. And I mentioned EarSketch because that's a great project I've heard of before. In fact, I think it's one of 2 at Georgia Tech, along with media computation. So we're not generating music with this. We're not using bad music to teach. These are all great ideas that I know other people are doing. I'm not recording music. And it's not just entertainment. We're really trying to get students engaged in what computing concepts are there. And I know this has been going on with a lot of the science disciplines. I think computer science has a little special connection with music, primarily for 2 reasons. One, computing can be defined as data and manipulating and representing data, as opposed to representing and manipulating sounds. And also it's a process that unfolds over time. So a lot of the stuff that I'm talking about, I can actually try and demonstrate in the music itself. So here's how I write a song. Here's how I try and write a song, okay? Think about what I want to try and do. And then I think about it for a while, listen to some music, think about music I've heard, and then usually go to sleep. As I wake up, does anything connect? And if not, I go back to number 2. So it may take a couple days for me to do this, but every now and then I get a connection and a little bit of a song comes together with the concepts I'm trying to think about. And after a little bit of massage, I play it for the class, and often the class will help me to finish this off. So it's hopefully not this bad, as I'm putting up here, but it's not an easy process. But it really does resemble sometimes writing a program. You know, you just keep trying it till it works. So that's the algorithm I've been using to try and figure out how to get a song to work. Oops, wrong plot. So here's the advanced stuff, and this is the one I'm going to try a couple of, is if I'm really lucky, I can find a simple enough concept that I can actually represent in the music itself. So my famous one is the recursion song, only because it's over 10,000 hits on YouTube. And there's a link to that there. I'm going to not play that one. But I'm going to try this song here called Stuck in an Infinite Loop. So Walter was nice enough to put this up on his site with all the words and the recordings right there. So let me see if I can do this. Can you hear this okay? If not, somebody will tell me.
You're good. You're good.
Well, I don't know how I got in this state. Hey, it seems I'm just a victim of fate. The loop that I wrote just doesn't work. Now I'm feeling like an infinite jerk. There's pain to the left of me, frustration to the right. Here I am stuck in an infinite loop. And I don't know what it is I should do. The debugger told me I'm really screwed. There's pain to the left of me, frustration to the right. Here I am stuck in an infinite loop. Well, it started with a freaking issue. Really thought I had a plan. Well, the monitor comes over, voice crystal machine, and says, "Seg abort, segmentation fault." Well, I don't know how I got it tonight. The progress condition just wasn't right. My brain is under way too much stress. Perhaps recursion would have been best. I was pain to the left of me, frustration to the right. Here I am stuck in an infinite loop. Here I am stuck in an infinite loop. Oh my gosh, I'm in an infinite loop. Help me please, I'm in an infinite. Until the point where the students get uncomfortable that they're going to miss their next class, and that's when I usually stop. So that's the idea of singing and putting the concept in there. So that's recursion and loops. I mean, you actually can do both of them. Okay. Another one I haven't really had the time to do yet, but I've got some sketched out about function calls and returns, because songs have choruses and stanzas and even bridges where you have to go off and come back to where you came from. So I'm hoping to put that in there. Parallelism is my newest one. I just taught a course in the spring where we did to the old row, row, row your boat to try and demonstrate pipelining, instruction level pipelining. So I had the students sing some lyrics to a song that I guess I could just show you, that talks about how to pipe data down and process it. So picture this, if you will, piping this down, a bunch of students singing this, one student at a time, and they have to pipeline it. So one student sings the first line, and then while he's singing the second line, the next person, she will sing the first line, and we'll go through, and hopefully we'll be faster. So we've been playing around with that as well. But the one I want to work on today was because I was challenged. So this notion of using changing keys and sounds comes in handy when I'm trying to do data sonification. So my panelist, what, a month ago maybe, said, "Do you think you could do a song with that? Using sounds to convey trends." So I can go through this much quickly because Judy did such a great job. It's useful for lots of people, but certainly with people with vision issues, but not only them. If you see it and hear it at the same time, you could argue you could get overwhelmed, but you might hear something you didn't quite see. So I woke up on a Saturday morning using my algorithm every morning, trying to think about what might work. And then on a Saturday, it happened. I got it right before lunch with that old Christmas carol I've heard around Christmas, "Do you hear what I hear?" So this one is going to be, "Do you hear what I see?" And I hope I do an adequate job because this is relatively new for me. But I did work indirectly with a student who was working on this for their thesis here at Haverford. And I ran the song by him. And he only suggested that one line that I have there in blue, if you're looking on the screen, that will change. Now, I hope I have this memorized, but I might not. So I'm going to reduce the screen here a little bit so I can get more of it up here. Okay. So here we go. This is called "Do You Hear What I See?" Said the scientist to the student there, "Now do you see what I see? Hiding in the data, student, where? Do you see what I see? A trend, rising to a peak. It's the slope of this line that we see to help find the time to the peak." Now said the science student to the scientist, "I can't see what you see. Might be vision or other impediment, but I can't see what you see. Perhaps there's another way to perceive this trend that you say. And for now, I'm stuck here today." to the data team. Just sonify the data. Using sound, you can see the data stream. If you sonify the data. Sorry, I gotta adjust the screen a little bit. It's not going down. There it goes. Sorry about that. Adjust the pitch, maybe amplitude or a tempo change. It can be good, and the point can now be understood. We'll send the data team to people everywhere. Now you can hear what we see. Vary timbre and brightness as you share. Then you can hear what we see. Oh, a graph is great, but only if it's seen. Sound is used to get at what's unseen and convey the point that we need. So that's the data sonification song, and I hope I didn't mess up what it's supposed to be about too much, okay? What actually happens for me personally is I learn a little bit about it because I had to go online and look up some stuff for some concepts that would relate. So certainly timbre and tempo and how the different things people use. So in conclusion, I just want to talk about where we stand with this. I do use this in class. Like the infinite loop song is pretty much all the intro classes get that. And I have other ones, recursion, and I have some songs about how to write code that so it doesn't mess up. So I have a song about, I fought the law on the law one, where my law is don't hand it in too late or something will crash. All those kind of things, make backup copies. I actually had people have submitted songs now, and I had one student submit the song before the course started. And later on I asked him, did it help? And he reported, it was neat hearing what these terms I had used in the song actually meant when we went through the course. And what's really fun is I get to be invited to outside events. So I've been invited to sing the Flame song, which is part of the Flame Challenge at a grade school. And I was a keynote at a conference, which just looking for different ways to engage people. And what I'm looking at now is, so I'm borrowing this from, I think it's the old Paul Simon, Still Crazy After All These Years. I'm still composing. And the latest work is really novel. It was suggested to me by a student at Swarthmore College, one of our sister schools. And what he was able to do was come up with his own original compositions for these three algorithms so far. And the lyrics in the song can be used as pseudocode for the actual algorithm. So we're going beyond just putting the concepts and even the concept being demonstrated by the music, but the actual introductory pseudocode for an algorithm as part of the code about a song, about the algorithm itself, that we hope people maybe can memorize as they're singing along and use it to get started. So this is my part of the presentation, talking about the computational singing project. And there's some information to how to contact me. And I put this up just in case. I saw somebody do this yesterday. It's on the list. And I'm hoping we can all take questions at this point.
Yes, absolutely. Thank you, JD.
Thank you.
Yeah, just speaking for myself, I thought the sonification song was rather brilliant.
Rather brilliant? Oh,
I'm
you're
impressed.
too kind.
You know, I'm like tweeting, I'm checking my email, I'm monitoring you guys, but it was still clear enough that I basically got the point of it. So that says something about, you know, your ability to communicate.
Well, this is something interesting to me. Like, not only would I like to ask Judy how I did, but I want to tell Judy, you do work with that, what was the gentleman's name from yesterday who sang about albedo?
Jargon.
Yeah, that you got to tell him that's a great, I went home and like told my kids, you got to look this up. And I could remember it because I knew the song, I'll Be There. I could just remember, oh, it's albedo. That's the effect I'm looking up. So,
Yeah. So attendees, please continue to send us in your questions. Please use the chat window or Q&A for that. Do we have any new Q&A things? I think these have all been, yeah, all the Q&As have been addressed. I guess the maybe just to get us started here, JD, my mind is kind of blown by the whole lyrics as pseudocode thing. I really wasn't ready for that. I'm just trying to wrap my head around it.
Sure. Would you like me to put it on my screen here? Would that be something useful?
Maybe, like, yeah, just a little example.
Sure. So.
And can you also just back up and explain briefly what pseudocode is for those who are not computer science people?
Sure. So actual code is you have a programming platform. For example, Judy mentioned Python, and that has an agreed upon syntax that must be unambiguous and precise. Pseudocode is the way that computer scientists will describe an algorithm, and we don't want to commit to any particular platform. So we want to talk about it in very general ways. But the good thing about that is no matter how platforms change, this will be hopefully timeless. And it's a way we communicate. So by putting it in a song, we're hoping that our song is not bound to anything, any particular instrument or any particular, it's kind of the same idea. The way we think about music as being abstract, pseudocode is an abstract way of thinking about an algorithm. And we want students to learn that, because I know myself years ago, I learned in BASIC in my first course. So we certainly don't want them memorizing Python. I don't know what's going to be in the future. So my screen, I guess I'll grab binary search. That's the first one that comes up. And this is, shout out to Ben Schreiber. He put this all together. And my big contribution was recognizing that this was really something we could use in teaching computer science. So this is the whole thing. You go here, and he usually has 3 videos. They're tutorials that we've been testing students at both Swarthmore and Haverford to see if it really makes any difference. And so far, a lot of the students are saying it helps a little bit, not as much as if I knew the tune already, because he writes the songs himself. So let me go here and see if I can get to the point in the video where he demonstrates as he puts the song up. It's like a little, what do you used to call it? Karaoke, where you just follow the bouncing ball and the code, the song will come up. Why isn't it coming up? Okay. How many times can I set this up here?
Of the mid, because we know
there it is.
Less than the mid.
I guess I have to pop this out
really,
somehow.
We only have to consider the mid because we know our key is less than the mid. Okay. So really,
that doesn't sound good.
To do this, we'll just set our high equal to mid minus 1. That excludes everything. So to
but I need the song. There it is.
Greater than your upper bound.
Okay. So I guess I should go back to this point if I really want to try and demonstrate it. Oh. Okay, this will be fine right here. So at this point in the code, those comments in there find the midpoint between the low and high indices, and even
on to the next.
There we go. Can you? Can't get it out of the way. Sorry, I wasn't planning to go here, but
neither of the two if conditions have been met.
Good. So that's the song that he's got right there. Those are the actual lyrics to a song. You can see where he has met rhymes with exet. Okay, it's pushing in the envelope, but he does have these things rhyming code. So these are the 4 lines from the code.
You found the key, so return the mid index.
And then it goes down into the code here, and you can see, I hope you can see, well, you can't see here if I get rid of this. There we go. That those lyrics are right there in the pseudocode. That's the comments. So in Python, you use this to say, this is just for people, not for the computer. But by pasting it in first, hopefully that will remind you or be a prompt for what kind of code in Python you would use. And we hope we can use this with lots of other languages. So that's the idea. Does that help?
It helps me. It still does sound very, very radical, very pushing the envelope.
Very much. Oh, yeah. I mean, we can go back and hear the song if you want a little bit. There's Ben. Ben is now, I think, at Capital One. So we're very proud that our graduates get jobs and such. There it is. So here's his song.
high you should iterate. Find the midpoint between the low and high indices, and if array mid is greater than the key, set high equal to mid minus 1, and keep the low position. Else if array mid is less than Dougherty, set low to mid plus 1 and let the high just be. If neither of the if conditions have been met, you found the key, so return the mid index. If from the while you happen to exit, then nowhere in your range does the key exist.
Okay. So there's a relatively complicated well, he's doing it as a loop, an iterative algorithm that many textbooks we have found have gotten it wrong, that we're hoping we can use to prompt students to keep getting it right. So.
Yeah, thanks for that.
No problem.
We have some more questions in the Q&A. These look like they're more directed to JD. I want to let Leah, keep Leah involved too. I'm just as sort of a fun mental exercise. As I said at the outset, I lumped you all together somewhat arbitrarily. I'm wondering if we could imagine a scenario when a student would sort of use all three approaches that we've heard about today. Like they sing a song about computing, as JD is showing us. They sonify some data, as Judy was showing us, and they use ear sketch, as Leah. Can we put that in some sort of semi-logical sequence just for fun?
What's that?
Yes, I think it's definitely doable. One thing with ear sketch is it doesn't have any sound clips that are lyrics. So if you wanted to, like, let's say, compose a song with John about like loops or another concept, and then you wanted to record yourself, and then you could use ear sketch to add like the instrumental of your song. And then, so I could see a relationship with like both things, but not the three things together. But you can also do sonification with ear sketch. So Judy worked a lot with pitch. So, if it's high pitch or low pitch based on the value, but you can also do with rhythms and things like that. So that's something you could do with ear sketch as well. Yeah. JD, do you have any ideas?
Any data for, sorry, I was answering another question on the text. So we actually, let me go back here, I guess. I don't know if my screen's up still or not, but where it says latest work is a link to a paper presented actually in Seattle last year that talks about some of the results we got. And the biggest issue that people reported, because we're always looking for how we can improve it, is I think Ben and I have to get together. So taking songs that people know, parodies, I guess you would say, made a bigger difference because nobody knew the melody that Ben was playing. He had written it himself. So that's a harder thing to do, I think, to have both of them together. But that's the place we're going to have to try to see if we can take the songs and put the algorithm in an existing melody that people know.